I'm Anil Kumar. Welcome to my new series for grade 8 students in Canada. This video is being prepared for Kate, my new student from British Columbia. All those who want to join and benefit may send me email. My email address is given in the comments, and we can take your questions while developing a curriculum for grade 8 students in Canada. I hope that will also benefit many students worldwide. So we'll begin with the topic square roots and Pythagorean theorem. I'll try to cover this in 4 videos. In the first one, we'll talk about squares, square roots and non-perfect squares. Then we'll take some questions based on this topic in second video. Third video, we'll talk about Pythagorean theorem, and the fourth video will be a test on the unit, square roots and Pythagorean theorem. So I hope that will help you a lot to understand all the concepts as we move along. Your suggestions are most welcomed. Now, what are squares? Let's begin with very simple numbers. So what I will do here is make a table in which we'll write some numbers. So let me say for me, n is any number. So I'll begin with numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9, and let's say 10. Now, square of a number we'll write as n to the power of 2. So we have to read this as square of number n, right? So you have to read this as square of number n, right? So n is our number. So square really means we have to multiply the number by itself. So when we say square of a number n, it really means what? It means multiply the number by itself. That's what it means. So when I say 1 square, it means I have to multiply 1 by 1. And so what I get here is 1. So square of 1 is 1. What is the square of 2? It is 2 times 2, which is equal to 4. For 3, it is 3 times 3, which is equal to 9. Now to multiply, we could use different symbols, right? We could write 4 times 4 as 4 brackets times 4 brackets. That is equal to 16. So we could write in brackets also like this. That also means multiplication. So 5 times 5 will be 25. So the numbers which I am writing here are actually square of the above numbers. 6. So we could write this as 6 square. That means 6 times 6. Now you understand, right? So it is 36. 7 square is equal to 49. That is 7 times 7. And 8 square is 64. How about 9 square? It is 81. And 10 square, as you know, is 100. 10 times 10. So those are squares of some numbers. Correct? So what we did here, we just wrote the squares of the numbers. So we'll talk about first 10 squares only for the time being, and then we'll kind of extend our concept. Now let me do the reverse thing. Reverse thing for me means that now I will write the numbers on the top with their squares. So I'm now writing these squares, which are these numbers. Squares are 1, 4, 9, 16, 25, 36, 49, 64, 81 and 100. Okay. Now these are the squares of the number. What are their square roots? So now we will write n, which is square root of above numbers. Do you see? So these are squares, so we'll write square roots. Square root means reverse process. So if I have to get the number back from the square, we do square root. Correct? So So n square root is n. To explain you this concept, let me take up the numbers themselves. So if I have 1, which is 1 times 1, right? So 1. So 1 times 1 and then square root is equal to only n. So one of those numbers, which is 1. Do you see that? So it is only one n. Did you see that n? So what I'm trying to say here is that when we have something like n times n within square root, then it is equal to the number n itself. Correct? So square root of n square is the number itself. So when you're multiplying a number by itself, then square rooting gives you that number. Correct? That's what we mean. So for example, how could I write 4 as? I could write 4 as 2 times 2 and then square root, right? So square root of 2 times 2 will be one of these 2's, 2. So in a way, square root is the reverse operation of square, right? So what we had here was that, let's say this is our input-output machine, right? So in the input-output machine, we had some input, and that input comes out as a square. So what is this doing? This is squaring the number. And if n is the input, it just squares and brings it out. So when I put 3 here, so we get 3 square, which is 9, correct? Now the other machine which I have is a square root machine. So the second machine which I have is the square root machine. So in this, if I put 9, what should I get? I should get my number back. You get the idea, right? So that is how the square root machine works. It gives you back your number. Perfect. Which you had squared earlier. So that is how it works. So earlier we squared some numbers, got the square of those numbers, and now we'll square root, get our numbers back. So that makes sense. So square root of 9 will be 3, square root of 16 will be 4, that of 25 will be 5, 6, 7, 8, 9 and 10. Got it? So this is how squares and square roots are working hand in hand. You see, one operation is reverse of the other operation. Perfect. Now the question comes, we have understood what is the meaning of squares, right? So we have understood squares. We know if I multiply these two numbers, I get square of a number. We have understood what a square root is, and that is, if I have a square of a number, I get the number back. Now, the third thing which we have to talk about is what is non-perfect square and what is a perfect square. Well, all these numbers which I gave you, they are called perfect squares, right? So these numbers which we talked about are called perfect squares. Why? Because they return you the number, right? So perfect squares, square root returns you the number. So square root of perfect square is equal to natural number. So you saw square root of 100 was 10, but that is not the case. So from 1 to 100, there are only these 10 perfect squares. All other numbers are non-perfect squares. You get the idea, right? So if I have to find what is square root of 2, what is square root of 3, what is square root of 4, what is square root of 5, all these numbers are not natural numbers. So if the square root is not a natural number, then we call them non-perfect squares. Does it make sense? So all other numbers will be treated as non-perfect squares. Only these 10 numbers from 1 to 100 will be treated as perfect squares. Perfect. Does it make sense to you? Now, whenever we have to find square root of these numbers, it will be in some decimal numbers, right? So the square root of these numbers will be decimal numbers. And that too, we have to estimate, approximate. Most of them may not be having exact values. So they are very different from the other numbers. So I hope you got the basic concept. Now with this concept, let's move on and take some examples, right? So I hope this diagram now is clearly visible. So what we learned here is that the square of a number is multiplying the number by itself. So what do you do here when you have to find square? Number times itself. Gives square of a number. Perfect. And square root is the reverse operation. Perfect. Now let's take few examples. In question number 1, we'll estimate each square root to one decimal place, and then you can check your answer with calculators. We'll also learn how to use calculator, right? Now we had these numbers which are perfect squares. And these ones are non-perfect. Let us first estimate. So when we do square root of 9, we just learned 9 could be written as 3 times 3. You can also write a dot, right? Which means one of these threes, square root of 9 is 3. If I do 3 square, I'll get 9 as my result. 16 is 4 times 4, correct? So I could write this as 4. 25 is 5 times 5. Number times itself, when you do square root, you get one of your numbers, which is 5. And 64 is 8 times 8. This is not decimal, this is multiplication, okay? So you get 8. The question is, estimate each square root to one decimal place. So let me write 0.0 for each, so it becomes one decimal place, and actually we get these as exact values, since these are perfect squares. Perfect. So that is how we understand what perfect squares are. Correct? You saw earlier. Look here. So all these numbers, 9 is there, right? Which we get here as 3 square, right? So that reverse operation, 3 times 3 was 9, and now square root of 9 gives you the number back, and we get our number 3 back. Perfect. Now square root of 18. How do I calculate square root of 18? Now here we need to estimate. The perfect square here is close to 18. We know 4 square is 16, and we also know 5 square is 25, correct? So if you have to find square root of 18, then how will you find it? Well, 18 is somewhere in between 16 and 25. So that means it is more than 4 and is less than 25. So slightly more than 4. So we could estimate this value as equal to more than 4. That means 4 point something. Very close to 4. So let's write 4.2. Does it make sense to you? So that is our estimate. Correct? So to estimate, we check for numbers which are perfect square close by. So in the second case, square root of 21. Now 21 is between 4 and 5, right? So 4 square, is 16. 5 square is 25. Somewhere in between, we have 20. Right? So 20 is almost in the center. So what we could write this as 4.5. So that is how you estimate your squares. Does it make sense to you? Correct? So use this method to estimate your squares for the numbers which are not perfect squares. 26 is more than 25. Sorry, this was 25. So 26 is more than 25. That means 5 square is 25. Next is 6, right? 6 square is 36. Now, 26 is just one more than 25. So I will estimate this as 5.1. Does it make sense to you? Correct? So that is the way to estimate. Now we have 72. 72 is more than 8 square. 8 square is 64. 9 square is 81. In between, we have 72. Since it is almost in between, I could estimate this more than 8 less than 9 as 8.5. Correct? Then you can check your estimates. So we have square root of 18. We can check the estimate. In my calculator, you have to press this button. So you get 4.24, right? Which is very close to what I estimated. Now let's do square root of 20. So we get 2 square root 5, which is 4.47. So that is also almost correct. And square root of 26 is equal to 5.09, right? So 5.09 could be written as 5.1, and square root of 72 is equal to, in decimals, 8.48, so 8.5 works. Do you see that part? So you could easily estimate square roots by finding perfect squares close by. So in between numbers could be estimated. Correct? Imagine the difference is 10, so 0.1234 to 9 will work for you. Correct? So that is how you do it. So I hope this concept is clear. Now let's move on and take question number 2. Question number 2. Estimate each square root to one decimal place. Check your answer with calculator. Now this time I have taken slightly bigger numbers. You will notice all are in their hundreds, but they are similar to perfect squares which we talked about. You can always pause your video, answer the question of this. Answer this question. So square root of 100. Square root of 100 could be written as 10 times 10. So we have two similar numbers. So square root should be equal to 10. Does it make sense? Perfect. So that is our exact value. Since we need to just estimate and write to one decimal place, I will write this as 10.0, right? 1600. Now 1600. Now you understand, square root of 100 is 10. So I could write this as 16 times 100. So when you work with bigger numbers like hundreds, you could do like this. Now what is the square root of 16? Square root of 16 is 4 and square root of 100 is 10. So it could be 4 times 10 or 40. Let me write 40.0 for the time being, right? So in this question, to one decimal place was not really required, right? So estimate each square root. That is not really required. You may check your answers with calculator. Now next one here is square root of 2500. So I could write this as 25 times 100, which could be thought of as square root of 25 times square root of 100. Now square root of 25 is 5 and that of 100 is 10. So we could write this as 50. Do you see that part? So that is how you could do with bigger numbers. 8100, I think is very clear. 8100 is 9 square times 10 square. 9 square is 81 and 10 square is 100. So I could write this as 9 times 10 or 90. Perfect. So I've shown you different ways of doing the same thing. Perfect. So that is how you could do it. Now this question is for you to practice. So let me write square root of 6400. Right. Use any of these methods and find your answer, the exact value. Let's move on and take question number 3. Estimate each square root to one decimal place given square root 2 is 1.414 and square root 3 is 1.732. Now here we are given the value of square root 2 and square root 3. These are very important values and therefore I have included them in my questions. You should remember that square root 2 is 1.414 and square root 3 is 1.732. Or at least square root 3 is 1.7 and square root 2 is 1.4. Perfect. Now let us see how to find square root of these numbers. So first number, square root of 200, you can think like this, 2 times 100, correct? Now we know 100 is 10 square, right? So you can say square root of 2 times 10 times 10, right? So that is 10, one of those comes out and we are left with square root 2. So that is another way of writing. It is kind of a mixed number, right? With square root and a whole number. Now square root 2 is 1.4. Multiplying by 10 means moving decimal to one place, right? So it gives you 14.1. Does make sense to you? So that is how we can actually write to one decimal place the answer. Next one, square root of 300 means square root of 3 times 10 square, right? Which is 100. 10 square is 100. So that means one of those 10s can come out. We have square root of 3 and we know square root of 3 is 1.732. So when you multiply, we just need to move the decimal one place to the right. We get 17.3 as our answer. Did you see that part, right? So 10 means move the decimal one place to the right. So now you understand how we could also work with non-perfect square roots, correct? Now you can pause the video, answer the question and figure out, or rather estimate square roots of 1800 and 5000. Okay, I will do it like this. I will write 1800 as 18 times 10 square. 10 square is 100. So get used to squares and square roots. So for 10 and we have 18, but do you know 18 could have been written as 9 times 2? 9 is a perfect square, square of 3. So I could write this as 10, right? And 9 is 3 square root 2. Because 9 is 3 square. So we get 30 times square root 2. Do you see that? So we get 30 times square root 2. So you have to now multiply 1.414 with 30. That is to say, 30 times 1.414. So when you multiply by 10, decimal moves one place, right? And then with 3, we need that first number, right? So when you multiply by 3, you get 3 times 4 is 12, 2. 3 times 1 is 3 and 1, 4. 3 times 4, 12, 2, 1. 3 times 1, 3 and 1, 4. You have to put decimal after 3 places, correct? And also a 0 because there is a 0 here, right? You have to put decimal after 3 places. So 1, 2, 3. So you get 42.42. Rounding to one decimal place is 42.4. Slightly complicated, right? So you could do like this. Perfect. Now, 5,000. How will you do this? 5,000, since we know, we could have written this as 900, right? We could write this as 2 times 2500. Do you see that? So which is square root of 2 times square root of, what is this? 5 square times 10 square. So what we get here is 5 times 10 is 50. We get 50 square root 2. Correct? To estimate now, you have to multiply 50 by 1.414. Or you have to multiply 5 by 14.14. You could do like this, correct? Now you can multiply. So 5 times 4 is 20. 5 times 1 is 5 and 2, 7. 5 times 4, 20. 2, 7, right? decimal after two places. You get 70.7 as your answer. So you get 70.7 as your answer. Do you see that? So this exercise is slightly more complicated, but definitely you should use calculator to check your answers. Perfect. I hope that is making sense. So whenever you have 100, you could write 100 as 10 square, 25 as 5 square, 18, 9 times 2, 9 is 3 square, so you get 3 outside. Perfect. So go through this and try to understand the logic which we have followed to answer these questions. Let's move on and take question number 4. Now this is an application question. A square has area of 200 meters square. So area, let me just make a square here. So the area is 200 meters square. So area equals to 200 meters square. Now for a square, all sides are equal. So what is the area equals to? Area is side square. So the sides should be equal to square root of A. That is how you find each side. Do you see that? The question for you is, estimate the side length of the square given square root of 2 is 1.414. Square root of 3 is 1.732. So basically, we need to find square root of 200. Do you understand? So let's find it. So we need to find each side is equal to square root of 200, which is, 2 times 100 or 10 square root 2. Correct? I could write this as 2 times 10 square, right? So 10 comes out 10 square root 2. So it means 10 times square root 2 is given to us as 1.414. So when you multiply by 10, you get 14.14. So that is your estimate, which is equal to option B. So that is your answer. Do you get it? It becomes much simpler now, right? So that is how we have to do it. And the units here, I should have written meters for each. Okay. Now here is the last set of questions, question number 5 and 6. I hope by now you must have become very familiar with square root. Question number 5. Find the number that has square root between 7 and 8. So these are your numbers. We want square root of the number between 7 and 8. Correct? That is what we want. So select the right option. Question number 6. Square root of 75 is approximately equal to what? Question number 6 is, you need to estimate square root of 75 is what? You can pause the video now, answer this question, and then check with my answer. Perfect? Okay. So let's do question number 5. Find the number that has square root between 7 and 8. So we know what is the square root of 64. Square root of 64 is 8 and square root of 49 is 7, right? So when we say a number whose square root is between 7 and 8, that means we are actually thinking about their squares, right? So any number which is between 64 and 49 will work for us. So in this particular list, we have 57, which is between 64 and 49, right? You could have seen it like this also. What is 8 square equals to? 64. What is 7 square equals to? 49. So we want a number in between, which is 57. So this is a better approach, correct? But you could adopt any one of these methods to find the solution. Perfect. Question number 6. Square root of 75 is approximately how much? So we have 75 and we know it is between what two numbers, which are perfect squares. 75, more than 75 is 9 square, which is 81, and 8 square is 64. So we are looking for a number in between these two. So in between these two means more than 8, less than 9. 8.5 is a good option. So option C is the correct option. Does make sense to you? So with that, we come to an end of our first video on this topic of square roots and Pythagorean theorem. We also had few review questions, or rather examples, in this particular exercise. Correct? Now in the next video, I'll take up Pythagorean theorem directly, and then we'll have a quiz and a test. Perfect? Feel free to write your comment, share your views. If there is something which you need to understand further, send me an email, right? And write your comments so that I exactly know that the whole exercise is beneficial for you. Thanks, Kate, and all the best.